So kinetic energy is an energy of a body because of its motion, by the virtue of its motion. Any object which is moving, suppose there's a ball moving, train moving, you are running, you're moving, even wind is blowing, everything has got kinetic energy. Even running water, moving water will have kinetic energy. So anything which is moving will have energy. And then we also discussed that why anything which is moving has energy is because that object which is moving will have some mass, plus it must be moving with some velocity, with some speed. That's why the formula of kinetic energy, the formula for kinetic energy is half mv square. Okay, you all have to remember this formula because it will be used while you're doing the numericals. Half mv square, it is square of the velocity and multiply by mass and then half of that. Now then we discussed one or two simple numericals, okay, after which we talked about potential energy. So what is potential energy? Potential energy is not because of the motion, but potential energy is because of the position of the object. Okay. One point to note here is that it is not that any object which is at rest will have potential energy. No, it is not that. Any object which has been moved to a certain height, which has been displaced to a particular height, okay, only will possess potential energy. Suppose if you all take your right now as you sit and sit during the class, if you pick up your notebook and you lift your notebook to a certain height, let's say few centimeters, now that notebook will gain potential energy. Initially while it was on the ground, it did not have any energy, but the moment you lift it up, even by few inches, even by few centimeters, it will have some potential energy. The more you lift it, the more energy it will gain. What kind of energy is that? Potential energy, isn't it? And that energy is because it has now gained some height. Now how do you check? Your brother or your sister can tell you, no, it does not have any energy. What proves? Prove me that it has got energy. So what should you do? You should just leave the notebook or leave the pen or anything that you're holding. If you leave it, if it comes down, that means it has some energy. Only because it has some energy, it is able to move itself without any force, isn't it? So that type of energy is called as potential energy. Arrow here, this is the arrow and this is the bow. When the person was not stretching it, the thread was straight like this, so the thread was in the original position, so no energy. As soon as the person stretched the thread, because the thread moved from this original position to this position here, the thread has been stretched. So because the thread has been stretched, it will gain some energy. And how do you check whether it has gained some energy? You will leave the arrow. Okay, you will leave the arrow. When you leave the arrow, if the arrow moves forward, so that means the thread has now gained some potential energy. Fine. Now if you have ever done it, you will know that the more the stretch, the more the potential energy. Okay, so that is what is potential energy. Suppose, look at this, the car goes up, okay, up the hill. Now the car has been raised to a certain height, so again the car will gain some potential energy. If you stretch the rubber band will automatically come back to its own position. Again it has got some potential energy. If you throw a brick or anything you lift in your hand, it has got some potential energy. Okay, let's say if you take a spring, okay, and push the spring automatically will come back to its own position. If you throw some stones from a certain height, they will go down, because once you lift these stones to a certain height, the stones will acquire some potential energy. It will have some potential energy, isn't it? So that's why this is the example of potential energy. The body has some mass, so m, plus the body has gained some height, so height is also a factor. Here speed is not the factor, but height is a factor, isn't it? That's why the formula for potential energy is mgh. The formula for potential energy is mass multiplied by acceleration due to gravity multiplied by height. So this is the formula for potential energy. Now suppose the pendulum is here. This is the ideal position of the pendulum. Okay, the pendulum is not moving, the pendulum is at rest. If I take this ball to one side and I leave the ball, so the ball is now will start oscillating like this, from left to right like this. Okay, when the ball goes to one extreme, it starts coming back for a very small moment. It stops here, okay, and then it comes back like this. Okay, then it goes on the other end and then it stops for a moment and then it comes back. So when it stops for a moment, the speed of the ball will become zero, isn't it? Because it does not have any speed right now, because it is at the extreme position here. Kinetic energy will become zero, isn't it? Because only in the kinetic energy you have V, half mv square. Fine. So here at this point as well as at this extreme point, the 2 points, the kinetic energy will be zero, but the potential energy will be maximum. The ball, the original position of the ball was here in the center. The ball has moved to a certain distance. Ball has been shifted to a certain distance here. Here the potential energy is maximum, because so at the two extreme position the potential energy is maximum, but in the central position the kinetic energy is the maximum. The box has been raised from point A straight to point B vertically up. This is the first path. Next time the same box goes to a certain height, travels horizontal, travels again vertical, again goes horizontal, again reaches the same position. Will the work done in both the case be same? You are applying the force in the upward direction, isn't it? And the box is also moving in the upward direction. So the work done is okay. Work done is there. Okay. But here what is happening? Look. For any vertical part, it is okay. Okay. But for the horizontal part, look at this. In the horizontal path, you are applying the force in the upward direction only. But where is the box moving? The box is moving in the horizontal direction. Work done will be zero. This horizontal path, the work done will again be zero. So what is the work done? Work done will be this plus this vertical path plus this vertical path. That's why the work done will be same in both the cases.